Boolean functions can be extremely useful. What do I mean by a Boolean function? Well, a function that returns whether or not something is true or false. So it just returns true or false. And we've seen an example of this in terms of is prime, because it allowed us to do stuff like, I don't know, from simply import is prime. It allowed us to do stuff like I for I in range 1 to 20 if is prime I. So it makes for a nice filter. And what I was able to do is I was able to get the primes under 20. So Boolean functions, very nice for filters. Let's try to make some Boolean functions. So we want, I don't know, let's start off with is 2-digit number. N. So I want this to return true if n is a 2-digit number. And I'm only thinking about positive integers here. I'm not going to try to make this work for positive or negative numbers here. Let's just make it work for the positives. And, you know, if it doesn't work for the negatives, but I don't need it to work for the negatives, that's fine. I know that Python tries to do its best to run functions. If I give it a silly output that's, you know, not intended, I'm not worried about that. So what do I need to know? Well, I want it to return true if it's between, inclusively, 10 and 99. And I want it to return false otherwise. So it seems like I might need some ternary expression here. And I could do it like that. I could say, hey, return true if, let's say, 9 is less than n is less than 100. Else false, using the ternary operator, and see how that works. Is 2-digit number, and 10 is going to work, 19 is going to work, 99 is going to work, 100 is not going to work. Okay, so this is working just fine. This is a lot more than I need here. I didn't need to go to the ternary operator because this piece right here is already a bool. You see, if I have 9 less than n less than 100, that's either true or that's either false. So there's no reason to have this on the left and this on the right. So what I could do is I could just do this. I'll get rid of that. And I'll get rid of that. And this works. It's much more compact. It's easy to read, right? I'm returning whether or not 9 is less than n is less than 100. And it works just as well if I have 100 or 99 or 10 or 9. It cuts off there and it returns false. So when you're making these Boolean functions where the output is supposed to be a Boolean, you know, you can use ternary expressions, but you can just look and try to see where is the bool, and maybe that'll shorten things for you. So let's do another one. Let's say has repeats. So what do I want from this? I want to tell whether or not our function has repeats. Our list has repeats. L. Let's use L. Let's say L is a list. So does it have repeats? That's what I want this function to do. Now, how am I going to write this? How am I going to tell whether something's repeated or whether it has repeats, which is actually easier than it is to tell whether a particular thing is repeated. Because if I just want to know whether L has some repeated entries, all I have to do is check the length of L versus the length of the set of L, right? Because the set would have a smaller length if it's containing repeats because the set takes out repeats. So let's compare. Let's say I have the set of L and the size of that set is less than the size of the original list. So let's see if this works. 1, 2, 3, 1. True, it has repeats. Okay. And let's do this. False, has no repeats. And how is this working again? Well, what I'm doing is I'm giving it a list. And what I'm doing is I'm saying, okay, let's compare the length of the list to the length of the set. If we were to turn the list into a set, if there's repeats, then I've just decreased the size of well, it's not a list anymore, it's now a set, but I've decreased the size by taking things away because the set will not allow us to have repeats in it. And of course, one more time, as I've beaten this to death a bit, but if I give this has no repeats, if I give this the set 1, 2, 3, 1, but I see 2 1s there. No, this is actually working. As long as I give has repeats a set, it's going to end up giving me false because a set has no repeats. If I write 1, 2, 3, 1, Python stores this the same way as it stores 1, 2, 3. And you'll see right here, 1, 2, 3, 1 is the same thing as 1, 2, 3. You can even check for equality here with that and true. So that, even though I see a repeated entry, this is the same as the set 1, 2, 3 because sets do not keep track of repetition. So those are some examples of Boolean functions and ways of doing it without having to necessarily do some sort of an if-else ternary operator statement.